Hey guys, welcome back. In this video, I'm gonna solve the fourth problem of the education code forces around 165. And yeah, totally there was six problems. I was able to solve two of them, and I wasn't able to solve from the C part. I already made how to solve C and minimizing the sum problem in the previous video. If you haven't watched it, you can search through my YouTube channel. You will be able to find this problem. And in this video, I'm going to discuss about the fourth problem. So comes the shop game, and it says that Alice and Bob are playing a game in the shop, and there are n items in the shop, and each item has two parameters, AI and BI. And AI is for the item price for Alice, and BI is the item price for Bob. And it has given two condition. Alice wants to choose a subset, possibly empty in the sense it can be none, like a subset can be none, or it can have any some number of items, for a subset of items, and buy them. After that, Bob does the following. If Alice bought K items, Bob can take all of them for free. Sorry, if the Alice bought less than K items, Bob can take all of them for free. Otherwise, he will take K items for free that the Alice bought. Bob chooses which K items it will be, and for the rest of the chosen items, Bob will buy them from Alice and BI for the ith item. And Alice profit is equal to this Bob's price minus Alice expenditure, where S is the set of the items Bob buys from Alice, and T is the set of items Alice buys. So from the shop, in other words, Alice profit is the difference between the amount of Bob pays her and the amount she spent buying the items. Alice want to maximize her profit. Bob wants to minimize the Alice profit. So basically, I'll be if you haven't understood the question, I will basically explain it in a few minutes. So if you try to see the test cases, what they've given it is one is the T. Commonly, they will be used to give the any all the questions like test cases, and next is N and K. N is the number of items in the shop, and K is the that check mark, like K items that Alice, if the Alice buys less than K, or otherwise Alice buys more than K, that is the K is a check mark items. Obviously, and K will be less than yet. And in the next line, for all the n items, like n they're giving, right, for all the n items, we will be having list of n prices, which is the Alice price in the next line, and the very next line we will be having the Bob prices. So basically, see, in a shop there are few items. For example, let's take 20 20, which means two items, and K check mark is 0, and we are getting Alice prices are 2 1, and Bob prices are 1 2. Basically what they are saying is, in a shop there are two items. Alice will first buy few items like that. We will not be knowing how much Alice is buying, and why, because we are the ones to decide how much Alice should buy. No, no, Alice will be buying few items, and from the items Alice bought, from there Bob will decide whether he is going to buy from Alice, or he is going to get it from free from Alice. So, for example, let's say, let it not the K check mark be 0, let it be 1. Let it be 1. Let's say in this two items, for Alice, she should pay 2 rupees for first item, 1 rupee for second item. And let's say Alice is buying, uh, uh, let it not be 1, let it be 2. Let's say Alice is buying one item, either of them. What the first condition says is, if the Alice bought less than K items, Bob can take all of them for free. Since, see, if the K is 2, Alice, if the Alice bought less than K items, less than two items, like buying one item, or if the, let's say, if this number is 4, and K is 3, I will be having adding one more price here, and just 10. Okay, and like case 3 here, if the Alice bought less than 3, like 2 items or 1 item, Bob can take all the items which the Alice bought for free. If she bought 1 item or 2 item, Bob will be taking that respect to 1 item or 2 item for free. He won't be paying anything to Alice, and it is like a loss to the Alice. Like she basically, what we should do, we need to calculate the Alice profit. If Alice profit, right? How much, and they are playing optimally, so Alice also wants to increase her profit, and that's why they said playing optimally. So it is like it is indirectly saying that Alice should not buy at all if she is buying items which is less than k. Number of items she is buying, if it is less than k, then it is as good as not buying the items at all. That's what the first point is saying. So see, if she buys less than 3, Bob will be taking it for free. It is like a loss for the Alice. Why? Because she is spending these many prices for the each item respectively. Second point says that if Alice bought, if the Alice bought otherwise, if the Alice bought less than k items, what is the otherwise meaning? If the Alice bought k or more than k or more than k, if the Alice bought more than k items, let's say for example, if here let it be 1, if the Alice bought 2 or 3 items, then Bob can take k items of the Alice for free, and rest of them he will be paying the prices, and Bob will be choosing which and all items he will be taking it for free, which k items he will be taking it for free. For example, let's say Alice is buying all the 3 items, then k is 1, right? Bob will be taking 1 item for free, and he will be paying the other 2 items money to the Alice. And basically basically if you are a Bob and Alice bought all the 3 items, then which item you will be buying, which item you will be taking it for free? Basically the last item, right? Why? Because if the Bob is not taking the last item, then the profit the Alice will get is -5. Why? Because she spent 5 rupees, but she will be getting 10 rupees from Bob. For the last item only, she will be getting profit of 5 rupees. So it is like a loss for the Bob. And I am again and again quoting that they said that they are playing optimally. So Alice also playing intelligently, Bob is also playing intelligently. Alice also doesn't want to minimize her profit, Bob also doesn't want to make losses by paying more money to the Alice. So he will be taking last item for free, and he will be paying money to the other 2 items. Let if we calculate profit for the other 2 items, -2 plus 1 is -1. It's a loss for the Alice for the first item. -1 plus 2 is 1, is a profit for, then overall net profit is 0. So overall net profit is 0 here in this case. So optimally, if the k is 1, Alice should not buy less than 1. So Alice will by buying most probably, most probably, most probably nothing. Why? Because even if she buys, the net profit is 0. Even if she doesn't buy, also net profit is also 0. Similarly, like that, you need to do and solve this problem. So it is basically, and this problem doesn't come under any kind of concept, so it is just basic math. So I'll just tell you what you can do. You can solve it using heap concept. Basically, I solved it using heap. Many of them used dp. I saw many other solution videos there, many of them used dp. So I solved it using heap. So basically what I did is I created a pair. It's like storing in a container with 2 values, x comma y. I know, I hope everyone would be knowing it, and if not, you can learn it from the Google. And pair, in that pair, I will be storing the Alice prices in the second position and the Bob's prices in the first position. So basically, if I take the elements of the pair, like say pair elements will be like this, okay? Set comma W, like that it goes on. In my pair, I will be getting first row, I'll be getting the Alice prices, next row I'll be getting Bob's prices. But in my pair, I'll be storing the Bob's prices as the first element, first Bob's prices as the first element, and the Alice prices as the second element. Then I will sort my pair on the basis of, always if you are sorting the pair, by default it means it is sorting according to the first element, which is the Bob's prices. It will be sorting in the increasing order of the Bob's prices. But Alice wants to make make as much profit as possible, so we need to reverse the sorted array. Now the array will be like a decreasing order of Bob's prices, like higher to the lowest. uh, we don't know what happens to the second element, but we surely knows that array is in like the decreasing size of the decreasing order of the Bob's prices. And I am creating a priority queue. Since it is I haven't mentioned anything here, just a int, and then it means that I have created a max heap, not a min heap. I hope you know the difference of declaring max heap and min heap. I've used the max heap. For min heap, you will be declaring like priority queue vector int, like int vector int, like that. But I have been declaring max heap. What is the basic concept of max heap is, max heap pushes the minimum most element at the top, and maximum element will be pushed at the bottom. Like it will be kind of like minimum element, like small, large, and the largest will be at the bottom. And this thing, it will be like a queue. I mean, it will be like a stack. Sorry, it will be like a stack, and minimum most element will be at the top, and maximum most element will be at the bottom. And basically, in the heap, I won't be storing all the elements. I'll be keeping that k check as a, you know, flag. Like once the heap size is becoming till then, I'll the elements which are adding to the heap, if it is if the size of the heap is less than k, I'll be keep on adding it to the variable sm. If it becomes more than k, then I'll be subtracting the minimum most element. Why? Because as per the Alice, I need to make as much profit as possible. So I will be popping it and I will be subtracting it. I will storing that in sm in on another variable answer. And you know what to do after that. It is the most easiest part. Just run the loop from n to k, and subtract the, what is the first, as I told before, first is the Bob's prices, second is the Alice prices. Subtract the Bob's prices with the Alice prices. That's what the profit is. And from the profit, I need to subtract this thing, the what I stored, right, the SM. That will give you the net profit and print it out. That's it. Uh, this is how I solved it without using DP, by using the heap and little bit of greedy. And thanks for watching this video. If you find any other solution, please post it in the comment section, and it will be helpful for me for the reference as well. Thanks for watching this video.